In part 1 of the video, we have drawn the graph of e to the minus x and the graph of x cubed to establish that these two graphs intersect at one point, somewhere between x equal to 0 and x equal to 1. Now, in the second step, we're going to use the Newton-Raphson formula to find a more exact route between this range. The Newton-Raphson formula is here on the top corner of this page. You can see there's x and plus 1. It's a subscript indicating the next value of x. And xn is basically the previous value. So it is a recursive formula, meaning that if you start with something, so just a quick revamp on what a recursive formula is. Recursive formula, if I give you a series, say 2, 4, 6, 8, and if I want to ask you, how do you calculate the next value by using the previous value? Everyone can tell me you just add 2. And this rule is actually a recursive rule. So if you add 2 from the previous one, you can get the next one. For this series, the recursive formula simply will be xn plus 1, so the next item, equals the previous item plus a 2. Okay, as a simple example of what recursive formula is. So in Newton-Raphson, we simply have to apply this recursive formula using what this formula says. This formula says I need the previous value and I also need a ratio between the function and the derivative of the function. So let's take a derivative of the function in the question first before we write anything else. So if the function of x is e to the minus x minus x cubed, then the derivative of this function, so taking the derivative of e to the minus x, is going to be itself times the coefficient in front of x, so minus. And then we're going to take a derivative x cubed, so power, multiply the power, and drop the power by 1, so 3 becomes 2. And that's it. So if we now write our Newton-Raphson formula, it would look like this. xn plus 1 equals xn minus, so the function, which is the first row, e to the minus xn minus xn cubed over the second row here, so minus e to the minus xn minus 3 times xn squared. I'm not even going to bother simplifying any of this because I am simply going to use a calculator from here on because this is numerical roots and we're not really bothered about the algebra here. Now, where do I start? In my series 2, 4, 6, 8, I started with 2. So in the Newton-Raphson formula, I need to know where to start. That's why our first step is important because it has given us an approximate range of where the roots might be. So I can either start with x equals 0 or x equal to 1. It doesn't matter. Sometimes Newton-Raphson will fail. If that happens, maybe try the other value. But usually, if it doesn't fail, then it doesn't matter which one you start with. So I'm going to say I will start with x1 equal to 0. And therefore, my next x, which is my x2, is going to be, so rewriting this whole formula, simply put 0 instead of xn everywhere. Okay, I got this one rubbed off. Okay, so 0 minus e to the minus 0 minus 0 cubed over minus e to the minus 0 minus 3 times 0 squared. Okay, a lot of you might say this is silly. You have a bunch of zeros and you're writing the whole formula very meticulously. The reason for that is you want to be writing that in your calculator exactly as well, because that saves you some thinking time. I know it's a lot more typing time, but later on you will find it more useful because you have to do this again for calculating the next x. And if you already have that in the calculator, you can just use your arrow button to navigate across the different places and replacing the 0 with the next value, which we're actually going to use the answer button. Okay, so I'm going to pause the video and go try to, you can pause the video as well if you want to try it. So I'm going to pause the video recording and then just go do my calculator and come back when I get a number. Okay, I've put all of that in my calculator and my answer is a 1. How funny. So maybe if I started with 1, I could have saved myself a step because now my input to the next x is going to replace all the zeros with 1s. But I'm not going to do that because what I want to do next is, whilst having this answer of 1 in the calculator, I will reload the same expression that I've just typed, and then instead of 0, I'm going to replace all the zeros with the answer button. So the answer button usually is next to your equal sign if you find it, and you can type that expression like so in your calculator. So answer e to the minus answer minus answer cubed minus e to the minus answer minus 3 times answer squared. Okay, and then get my next x value, which is x3, and that value is 0.8123. The question asks for 5 significant figures, so I'm going to keep 5 significant figures and see when it converges to those digits not changing. Okay, so next you're going to say, I have to do this all over again, but because I've already typed this in and that is shown on my calculator screen, I simply need to press the equal button. It will calculate the same expression using the answer from the previous step, which is 0.81231. Actually, if I write it accurately, it'll be 0.812339 ... So I'm keeping that answer inside the calculator so I don't have any rounding error to deal with. So x4, I can simply press the equal button. The calculator will do that same expression one more time. That gives me 0.77427 ... Okay, keep going. Press the equal sign again. That will give me the next button, next value, x5. That is 0.77288. Okay, it's looking like the gap is narrowing between one answer and the next. They're getting very close now to each other. So I will do that again. X6, press my equal button. I have again obtained 0.77228. The rest of the digits are a little bit different, but for 5 significant figures, they actually stayed the same. So I conclude that is my Newton-Raphson numerical approximation solution accurate to 5 significant figures. And that's it. Simply using the recursion formula by inputting the last answer into the same expression over and over again. All right, thanks for watching.